order to answer the problem, we would first need to know what is differential calculus. So differential calculus is a subfield of calculus concerned with the study of the rates at which quantities change. It is one of the two traditional divisions of calculus, the other being integral calculus. So after knowing the definition of differential calculus, we should now know why students of engineering and sciences should learn calculus. So engineering and science students should study calculus because firstly, it provides them with a powerful tool to analyze the physical world, and secondly, a triumph of imagination and analysis. Differential calculus, which I would describe as a mathematics of change, is incredibly useful for analyzing the movement of fluids, the flow of heat, the rates of chemical reactions, the effect of changing electrical and magnetic fields, the movement of machines, and numerous other engineering examples. We should now know the specific skill sets needed for us to excel in calculus. So one of the skill sets needed is the basic understanding of the concepts of algebra, trigonometry, and analytic geometry. The algebraic skill sets needed are factoring, completing the square, basic functions and transformations, simplifying expressions, and formula manipulation. Then the basic trigonometric skills needed are knowing the basics like the angles, trigonometric function, inverse functions, and the Pythagorean identities. And lastly, the basic geometric skills needed are the understanding of the formulas for area and circumference of triangle, circle, rectangle, the formulas for the volume and surface area of a prism, cylinder, pyramid, a cone, and a sphere, and other formulas that may be needed. So the problem is, the total weekly cost in dollars incurred by the Herald Media Corporation in producing X DVDs is given by the total cost function, Cx is equals to 2,500 plus 2.2x, with the number of DVDs produced not exceeding 8,000. What is the marginal cost when x is equals to 2,000? And find the average cost function and the marginal average cost function. And we would calculate both when x is equals to 2,000, and we should interpret that. So with the given function, we would first find the marginal cost when the number of DVDs is equals to 2,000. To get the marginal cost, we would first need to find its derivative. So the first derivative of the given function is 2.2, and substituting x with 2,000, it will still be at $2.2 per DVD. So the interpretation of that is the marginal cost when producing an extra DVD is estimated to be $2.2 per DVD. The second thing we need to find is the average cost function and the marginal average cost function. And we need to calculate both when x is equals to 2,000. So the average cost function is equals to the cost function over the number of DVDs produced. Using that formula, we derive the equation 2,500 plus 2.2x over the number of DVDs produced, which is x. And the marginal average cost function is equals to the marginal cost over the number of DVDs produced. Using that equation, we derived it using the quotient rule, producing negative 2,500 over x squared. Now using the derived equations, you will now solve for both total average cost and the marginal average cost. We will equate both x's to 2,000, starting first with the total average cost, which is equals to 2,500 plus 2.2 times 2,000 all over 2,000, which is equals to $3.45 per DVD, which means that each DVD costs about $3.45. Now for the marginal average cost, it is equal to negative 2,500 over 2,000 squared, which is equals to negative 6.3 times 10 raised to negative 4. We cannot have a negative answer, which means that there is no marginal average cost.